this is your hacker Nicole Cyan. Welcome to the stream. Hello. It's been a while. Welcome Havnia. Welcome Bima. Welcome Nick Works. Welcome Keijo. Welcome Dragon. Welcome Capri. Pray for your sanity. I hope your sanity is alright. Welcome Atom. Welcome Mona the Cat. Welcome Iron Primus 5. Welcome Ahmad. Welcome user 670. Welcome Tempest Magia. Welcome Batomi. Welcome Team. Hisashiburi desu. Welcome Warrior-san. Welcome DOX 539. Welcome Anna. Welcome Lixa H. Welcome. Hello. Oh my god, it's been a while. And I kind of just disappeared. Thank you for becoming a member. I don't know what you did. Let me actually read it. Did you send a message? Hello, Ice Cat. Yes. Yes, it's really been a while. I kind of had a not so good week. But things are okay. Things are okay. I think I should give an explanation. So basically, I wasn't feeling well last week or for a few months. There's something going on. And I feel like I need to go to the doctor, so I went to the doctor. I went to the doctor this Monday, and doctor wasn't saying very good things. But it wasn't horrible. It wasn't horrible. And after the visit, I was kind of shocked. I was kind of shocked, and I was like, wait, how should I plan forward? So, but I got some medication, and I have more visits scheduled. And the few days before, I was sort of on the extreme of my thinking, so I didn't want to make any decision like quickly. So today, I'm like, I'm feeling better. I should finish the Rust book. Like, this is something that I started. I absolutely should finish the Rust book project first, and I'll see what to do from there. It's nothing absolutely horrible, or I don't know yet. But after the medication, I'm feeling better. And besides that, there are some changes in my life happening. So it might involve me devoting some time to other projects that I need to work on, so Cyan can keep progressing on her life, and maybe also includes moving. So future is a little uncertain. So that's why I kind of went silent, kind of sort out what's going on, and I came back today. We first Rust and conquer the world. First Rust and conquer the world. Yes, that's the plan. That's the plan. So I'm joining a secret government hacking group. I hope the Anonymous wants me. That'd be really cool. Yes, YouTube is finally letting me stream Unsafe Rust. I know. They finally allow me to be unsafe and not against their terms of service. That's awesome. That's awesome. Yes, I'm definitely feeling better. I did realize recently I won't be able to do like endurance streams or anything like that. I might I might take a break after I finish Rust. I don't know how long it will be. It could be a week or two, or you could be even longer, but I don't plan to graduate, so don't panic. And yeah, I've been working on something to show you guys. So it's gonna be okay. It's gonna be okay. Yes. Hope everybody is enjoying this beautiful spring weather. I absolutely love all the sunshines and flowers, and I saw some birds making nests near my home, so it just feels like, you know, life will be good. Life will be good. And I hope everybody take care of your health and enjoy this amazing time of the year. Thank you guys, thank you K9， thank you Eric。也喵能愉快的摸鱼，是的，现在就是以身体状况为重，然后逐渐的把生活一些混乱的地方调理清楚，可能会休息一阵子，然后再看，然后但是是不会毕业的，可能会休息一阵子，然后可能以后直播还是做视频会有一定的调整。Yep, I was also thinking about whether I want to continue to be regularly streaming on a schedule, or just stream whenever I have time to, or instead I can kind of try the YouTuber route. So I'll really see, but I'll always be there. Even if I stop doing the videos, I'll still live as Cyan. I might do some projects, who knows. I'm always your hacker Neko. I don't see myself or any of my account go dead any days. So yep, so rest assured. Alright. That was a long speech then. I was thinking what I should say, but seems like it went well. So let's go to the Unsafe Rust and all the advanced features. Yosh! What do we have here? By now you have learned the most commonly used parts of Rust programming language. And before the big project, which is going to be probably next week, we're going to look at a few aspects of language that you might run into every once in a while. You can use this chapter as a reference, and the features you learn are useful in very specific situations. So they're not very common, but they're features that Rust offers. There is Unsafe Rust, which is how to opt out of some of the Rust guarantees and take responsibility for manually upholding those guarantees. And advanced traits, associated types, default type parameter, fully qualified syntax, super traits, and new type pattern in relation to traits. Wow, I recognize none of them. They sound complicated. And advanced types. New type pattern, type alias, never type. There's a never line and there's a never type. And dynamically sized types. Advanced functions and closures. Function pointers and returning closures. And macros, like macaronis. Ways to define code that defines more code at compile time. So I looked at this chapter before, and it's quite long, so I'm wishing we could finish the first two, Unsafe Rust and advanced traits. It's a panoply? What is panoply? What is panoply? Does it have anything to do with frying pan? Panoply? What is panoply? A complete or impressive collection of things. Okay, panoply. That's panoply of Rust features. So let's go. Let's go. Unsafe Rust. We're cracking the Unsafe Rust with my cat. Panoply seems like a made-up word? No, Google it. It's actually a real word. I just Google it. I admire how vast the English vocabulary can be. Okay, Unsafe Rust. So far we have memory safety guarantees enforced at compile time. However, Rust has a second language hidden inside it that doesn't enforce these memory safety guarantees. It's called Unsafe Rust and it works just like regular Rust, but it gives us extra superpowers. Superpowers! Let's go. Unsafe Rust exists because by nature, static analysis is conservative. So if you want to do something that's non-conservative, you need to use Unsafe Rust. Is that what's happening? So the compiler will reject some programs rather than accept some invalid programs. And sometimes when code might be okay, the Rust compiler doesn't have the confidence and will reject the code. And in those cases, we can use unsafe code to tell the compiler, trust me, I know what I'm doing. The downside is that you use it at your own risk. If you use unsafe code incorrectly, problems due to memory unsafety, such as no pointer dereferencing, can occur. So basically, Unsafe Rust, it's just me telling the compiler what I am doing is correct. Please compile my code. I'll be a responsible netcode for my code. Programming macaronis. That's better than spaghetti, I suppose. Welcome, Black Song. Basically, Unsafe Rust is where you deal with untyped invariants on which memory safety depends. The S keyword. Look at me, I'm the borrowed checker now. Wait. Why? Because you are your memory address? Hello, Adam, welcome. So now we are back to magic. Exactly. She's really locking away. She has many friends who care for her. Yes, I'm super grateful for that. Yes, sir. Alright. Next line. So why does Rust I want to rest so badly. Rust have an unsafe alter ego. You call it alter ego, okay? It's the reason that Rust has an unsafe alter ego is the underlying computer hardware. It's inherently unsafe. So it's saying everything we are looking at right now is unsafe. So it's basically allow us to do something. Otherwise, we won't be able to accomplish it. Rust needs to allow you to do low-level system programming, such as interacting with operating system or even writing your own operating system. Working with low-level system programming is one of the goals of the language. Okay, so how do we do it? How do we unleash the unsafe superpower? To switch to Unsafe Rust, use the unsafe keyword, and then start a new block that holds the unsafe code. This is like anime. This is like when magicians have like this scope. They have this magic location. They have the giant star with a circle on the ground. What I'm talking about. It's an unsafe playground. You can take 5 actions in Unsafe Rust. It's there's a number 5 actions called Unsafe Superpowers. Wait, that's a real word? I thought that was a joke. That you can't in Safe Rust. Those superpowers include the ability to dereference a raw pointer, call an unsafe function or method, access or modify a mutable static variable, implement an unsafe trait, access fields of unions. What are those? What are those? But that's the 5 superpower. We can dereference a raw pointer, call unsafe function, all of the stuff. What is that? Union? Onion? Okay, we'll see. It's important to understand that unsafe doesn't turn off the borrow checker or disable any other of Rust safety checks. If you use a reference in unsafe code, it will still be checked. The unsafe keyword only gives you access to these 5 features that are then not checked by compiler for memory safety. You'll still get some degree of safety inside of unsafe block, so sometimes it's just lower level of security. Think of union as untagged enums. Oh, what is tag? But I feel I'm going to reach it eventually. I'll be able to see what they are. Welcome, Exia! It's like enum, except it doesn't tell you which variant it is. You need to know. Ooh, you need to know. If you know it, you know it. If you don't know it, you don't know it. It makes me curious. Bye bye Tommy, thank you. I'm gonna have unsafe superpower like right now, yes. Yeah, open question about unsafe stuff. There's where nobody is quite exactly sure what's the undefined behavior in certain cases. Wow, it feels like clicking the nuclear button. Unleashing the dark magic. In C, it's like struct, but all the member items are in the same space in memory. So for example, you can treat the same space like multiple different types when each is needed. Oh, that's a union. All fields of union have a common storage. What writes to one field can overwrite other fields. Ooh, so it's like structs. It's making more sense. It's making more sense. Nice. Welcome underscore. Resto Nomicon. Scared. I'm terrified. Okay, what are we? Where are we? We are potatoes. We're not potatoes. I'm potato. Wait, where was I? Okay, I think I was here. So unsafe doesn't mean the code inside. It's dangerous. The intent is, as a programmer, you are ensured code inside an unsafe block will access memory in a valid way. Okay. So basically it's me taking responsibility. Keep unsafe blocks small. You'll be thankful later when you investigate memory bugs. Okay, I'll keep it small. To isolate unsafe code as much as possible, it's best to enclose unsafe code with a safe abstraction and provide a safe API. Ooh. So when we use the code other people write, we need to know if that code is safe or not. Parts of standard library are implemented as safe abstraction over unsafe code that has been audited. Wrapping unsafe code in a safe abstraction prevents the uses of unsafe from leaking out into all the places that you or your users might want to use the functionality implemented with unsafe code, because using a safe abstraction is safe. So we need to wrap the unsafe code in the safe abstraction. Let's look at each of the 5 unsafe superpowers. Okay. And abstractions. Nice. I thought you were a hacker, Neko, and not potato. I can be both. I can be a hacker, Neko, potato. It even rhymes. I'm genius. If you do any graphics programming, you will probably use a lot of Unsafe Rust. Why? Like 3D graphics? There's some decent abstractions these days. Welcome, Bruce. Hakaneko Potato. I'm Hakaneko Potato. Welcome, Mr. Lucas. To write a safe function which has unsafe blocks inside of it, other code can trust your safe function, while your own safe function has to be strictly audited. So I need to be responsible for my unsafe code. Mr. Wayne? Mr. Wayne, welcome. Okay, dereferencing a row pointer. I think this is ow thing, so it's row pointer. So compiler ensures references are always valid. Unsafe Rust has 2 new types called raw pointer that are similar to references. As with references, raw pointer can be immutable or mutable and written as const t and mut t. With the little star. Cause it's pointer. The asterisk isn't a dereference operator, it's part of the type name. In context of raw pointer, immutable means that the pointer can be directly assigned to after being dereferenced. So when I dereference the pointer, it cannot be directly assigned to. Okay. Different from references and small pointers, raw pointers are allowed to ignore the borrowing rules by having both immutable and mutable pointers, or multiple mutable pointers to the same location. Aren't guaranteed to point to valid memory. Are allowed to be null. Don't implement any automatic cleanup. Oh, it doesn't have automatic cleanups. So you can just be left there. In order to interact with GPU, you need to write to specific places in memory, which requires pointers. Oh, that's why graphic programming needs so many pointers. That's so cool. I bet there are some game programmers here. That's so cool. Asterisk const is just the raw pointer version of reference t. 欢迎小西瓜 welcome. Raw pointers are basically just C pointers. That makes a lot of sense. They're just C pointers. By opting out of having Rust enforce these guarantees, you can give up guaranteed safety in exchange for greater performance or the ability to interface with another language or hardware where Rust guarantees don't apply. So to create an immutable and a mutable raw pointer from reference, why am I typing it? because I want to. Immutable num equals to 5. Let raw pointer 1 equals to reference of num as const I32. And let raw pointer 2 equals to mute num as raw pointer. Even though I'm not using them. Can I run them? No problem, just some warning. Okay, so why don't we have unsafe keyword in this code? Because we are not using it, right? We can dereference raw pointer outside an unsafe block. So just declaring it doesn't need to be an unsafe block. We create raw pointers by using s to cast an immutable and mutable reference into their corresponding raw pointer types. Okay, so we use s to cast reference into raw pointer. Because we created them directly from references guaranteed to be valid, we know these particular raw pointers are valid, but we can't make that assumption about just any raw pointer. So we know this is valid, we know those are valid, but not all raw pointers are valid. So this. You wanna eat cat? What's wrong with you, Rigo? Is that how you greet me? That's rude. I'm going to put you in a dark room. Welcome, Rigo. So we have a random address 0x01234 5 U size, and we pass it. We create a raw pointer const I32. I wanna eat apples. That's amazing. Go ahead. Apple is good for your stomach. Welcome, Mitama. Japan kara ohayo. Japan? Japan? Ohayo. It sounds bad if you translate from Chinese to English. Did you not know what you just wrote? Okay. We have our address and then we pass it as a raw pointer. Honestly, if I print it, what's gonna happen? What exactly is gonna happen? Is that how you print line Rust? It's gonna have nothing, right? It's gonna be... Can I do this? What's the syntax? I completely forgot. Oh? No. Oh, this is tragic. Is it just this? Oh, it cannot be formatted. Okay. I stopped trying to print it. Recall that we can create raw pointers in safe code, but we can dereference raw pointers and read the data being pointed to. We can dereference it we can dereference on a route pointer that requires an unsafe block. So wait, I can print the pointer. What's gonna be in it? Wait. Oh, it's just printing the address. Okay. Okay. Thank you. And so here we have the unsafe block because we're about to dereference this bad boy. Print line. I want a sec for it. Yeah, I it's so tempting. I do want the segmentation fold. I wanna see the segmentation fold. I'm sure eating meat is just a joke. Right? What is going on? This chat is violent. It's against animal law. Oh my god. Oh no, it doesn't oh wait. Lesson learned. I should put in unsafe block so I can dereference route pointer. Look at this smart cat. She learns. She does learn. Now show me segmentation fault. Wait, what? Oh! We have the segmentation fault. Yes! Yes! I love it. Just kidding. I just want to see it. It's like visiting a zoo and you see this big elephant. Segmentation fault. Okay. Let's not have segmentation fault. So I want to print R1 and R2 when it is dereferenced. Let's go, baby. Print me 5. Done. Amazing. You already have an onion ring, but if blue, so I don't know if it's already rotten. Even if it's rotten, it's not blue. Blue is magical. What the heck? What the heck? And that's not onion ring. When did we decide that's an onion ring? The tattoo on my body is not onion ring. It's a cat. It's a cat. Ooh. Creating a pointer does no harm. It's only when we try to access the value may have end up with invalid value. Okay. That's all good. So why would we ever use route pointer? One use case is when interfacing with C code. We're mixing up C code with Rust. Ooh, swirl. Another case is when building up safe abstractions that borrow checkers don't understand, or introduce unsafe functions and then look at an example of a unsafe abstraction that use unsafe code. Okay. That's the first use case. That's the first power of Unsafe Rust, dereferencing a route pointer. Onion flavor Cyan. You! Cat hates onion. Shut up. Shut up. Okay. Calling an unsafe function or method. The second type of operation that requires unsafe block is to call unsafe functions. Oh, so besides unsafe code, we have unsafe functions. Do we have unsafe struct and unsafe enum? Unsafe functions and methods look exactly like regular functions, but they have extra unsafe before the rest of definition. Oh. There are many unsafe keywords to use, huh? It indicates the function has a requirement we need to uphold when we call this function, because Rust can't guarantee we met this requirement. By calling an unsafe function with an unsafe block, we're saying that we've read the function's documentation and take responsibility for upholding the function's contracts. So if there's an unsafe in a function, we put them into unsafe code. Risk acknowledged. We have unsafe traits. We don't have unsafe struct and unsafe if now. Okay. I was just brainstorming. We can have unsafe rust. So, unsafe function goes like this. Dangerous. It could be so dangerous. And when I call it, it needs to be unsafe block. Is this how I do it? Can Rust allow empty functions like this? Come on. Oh, did I just put a danger? Dangerous. Yep. So if I don't put it into unsafe block, does it complain? It does. What does it say? Call to unsafe function is unsafe and requires unsafe function or block. So you need to contain the bad boy, because it's unsafe. Like this. Squiggly line gone. A union is kind of like unsafe enum. Ooh. Oh, data can be unsafe, but code can be. That makes sense. An onion is kind of unsafe. It makes you cry. It makes you cry. Oh, so since we have told that this function is unsafe, the body of the function doesn't need more unsafe. You can just write the code. It's nice. Creating a safe abstraction over unsafe code. Just because a function contains unsafe code doesn't mean we need to mark the entire function as unsafe. In fact, wrapping unsafe code in a safe function is a common abstraction. As an example, let's study a function from the standard library, split at a mute, that requires some unsafe code and explore how we might implement it. The safe method is defined on mutable slices. It takes one slice and make it two by splitting the slice at the index given as an argument. So basically, you have this vector of numbers at mute vector equals to a vector of 1, 2, 3, 4, 5, 5, 6, and let R equals to the reference, the mutable reference of that vector. Oh. And we are going to split it at index 3. So 0, 1, 2, 3. And it's probably not including the ending index. Yep, it doesn't include the ending index because it's a parenthesis, not a square bracket. So it's 1, 2, 3 and 4, 5, 6. So after that we assert A is equals to mutable reference of 1, 2, 3. It's a string slice. And B is equals to 4, 5, 6. Does this work? Surely it does, because it's a library. It does work. Unsafe sign the flip. Maybe me flipping is not unsafe. Oh my god. That's funny. Flip. And we're looking at how do we implement the split at mute function. So we calculate the length of the slice, and we make sure the point we're slicing is within the vector's range, and we return the first half of the slice and second half of the slice. And this is wrong. Why is this wrong? Why is this wrong? This is because they're borrows. They're multiple borrows. The function will panic. Oh, the function will it panic? It won't be able to compile because there are multiple borrows. It's been borrowed twice. The slice has been borrowed twice. Even though those two are not overlapping, the compiler doesn't know that. So it's actually unsafe code. Actually, I think I can jump at this definition. See? It's unsafe. So unsafe. So for this long of we learning Rust, we didn't know that many functions we are using are unsafe. We use the length method to get the length of a slice. And use this method to access the raw pointer of the slice. In this case, because we have a mutable slice to integer values, this returns a raw pointer with type mutable integer, which we have stored in a variable pointer. This is the unsafe code. From raw parts mute. It takes a pointer and a length. And then it creates a slice. Slice from raw parts mute. I didn't know there are so many tiny functions. Slice from raw parts mute is unsafe. This is unsafe. Slice from raw parts mute is unsafe because it takes raw pointer and it must trust that the pointer is valid. Then the add method. Where's the add method? The add method on raw pointer is also unsafe, so this is unsafe. Because it must trust that the offset location is also a valid pointer. Therefore, we had to put an unsafe block around our calls to from raw parts mute and add, so we could call them. So we have a unsafe here. Oh, the first time I look at this, I didn't go in so deep. There's so many functions. Pretty much every single operation you do boils down to some unsafe primitive thing. Oh my god. So we have like tippy toes. It's dangerous everywhere, but it seems safe. The caller must uphold the safety contract for from raw parts mute. Note that we don't need to mark the resulting split at mute function as unsafe, and we can call this function from Unsafe Rust. We have created a safe abstraction to unsafe code with an implementation of the function that uses unsafe code in a safe way, because it creates only valid pointers from data this function has access to. The use of slice from raw parts mute. From raw parts, so here will likely crash when the slice is used. The code takes arbitrary memory location and creates a slice 10,000 items long. Wait. From raw parts mute. We have an address, and we're turning this address into a raw pointer. And here's an unsafe block that takes memory location and creates a slice this long, and it could be unsafe. We don't own the memory at this arbitrary location, and there's no guarantee that the slice this code create contains valid integer values. Attempting to use slice as though it's valid slice results in undefined behavior. But what happens if I run it? So it can be compiled. Let me try. If you're lucky, you'll crush. I wanna see if I'm lucky. Am I a lucky cat today? To crush a program. No, it didn't crash. How disappointing. Do I have to actually use it in order to have it to crash? Can I print it? What happened? Yes! Segmentation fault. I broke it again. Yes. Alright, that is unsafe. That's abstractions, right? Safe abstractions around unsafe function. Yes, safe abstraction over unsafe code. Congratulations, Seku. Using external function to call external code. Sometimes your Rust code might need to interact with code written in another language. For this, Rust has a keyword extern that facilitates the creation and the use of a foreign function interface, FFI. And FFI is a way for programming language to define functions and enable a different programming language to call these functions. Ugh. How to set up an integration with absolute function from the C standard library. That's lame. Functions declared within external blocks are always unsafe to call from Rust code. The reason is that other languages don't enforce Rust rules and guarantees, and Rust can check on them, so the responsibility falls on the programmer to ensure safety. Okay, let's grab some C code. Let's grab some C library. This is, I don't know why, but I feel excited. Normal cats just knock off stuff from counters. Cyan tries to access unauthorized memory location. Isn't that amazing? Amazing? Amazing. So we're taking this lame absolute function from C? Do I have C? How does it do it? A main function, and when I use it, I need to say, I don't trust C. Print line. Amazing. Amazing. I am amazing. Absolute value of -3. What? Just like this? Can it run? It did run. It did run. I mean, like, can I do this? Oh. Valid ABI Rust C. What? Did I understand it completely wrong? I can only do C? Why can't I? Amusing. That's a nice word. Science sequel to a program I was forced to watch. I know this is terrible. I'm a terrible cat. That's what's amusing about being a cat. I need to link against it at compile time like you would in a C project. Never done it myself. Just use some library which did it for me. Wait. Then what are other values that are allowed in here? Like if I put B, it's not okay. I can do Rust. Is this redundancy? Okay, I am a redundant cat. What's wrong with that? There's nothing wrong with that. Cool. Application binary interface. It's like all the different programming languages decided on how C works as a sort of common ground for how to call functions. Oh, so it needs to be a common ground. So cool. Oh, when you see the title, you thought it's going to be Rust again? Many people said that. I didn't even know Rust was a game back then when I started. Welcome, Shikari. Hello. We can also use extern to create an interface that allows other languages to call Rust functions. Instead of an extern block, we add the extern keyword and specify the ABI to use just before the function keyword. Oh, so we don't need a block? And no mango. What's wrong with tropical fruit? Mangling is when compiler changes the name we have given a function to a different name that contains more information for the other parts of the compilation process to consume but is less human readable. Oh, so don't mangle the name of the function. Keep it the same. So for a Rust function to be nameable by other languages, we must disable the mangling. No mango. What does mango mean? Mango? Why is there a stupid rabbit with skeleton? What is wrong? Oh, it's really called mango. Mango. It sounds the same as mango. The fruit. So severely mutilate, disfigure, or damage by cutting, tearing, or crushing. This is a horrible name. So basically, it's like, don't hurt me. Don't change the name of function. Okay. Can I hack your heart? Sure. What's the interface? Oh, you like mango? I like mango too. I like mango too. Wait. So instead of this extern block, we can do no mango public extern C function call from C print line. Just called a Rust function from C. Wait, what? Wait, what? Is this what I'm supposed to do? Oh. It's not extern. I saw the squiggly line. I panic. Hi. A Rust function from C. Oh. Now there's no more absolute. Call from C. We make this function accessible from C code after it's compiled to a shared library and link from C. Ooh. Mango means the compiler changes the name of functions to something a lot uglier but more descriptive. Is it like sort of like changing into machine code but not really, like in the middle of that, so the machine can read it better? I am not a low level person. I don't know much about what's going on under the hood. I bet those names are really long. Accessing or modifying a mutable static variable. That's a lot of words. Mutable static variable. Is that the so-called global variable? Until now, we have not talked about global variables, which Rust does not support. Okay, so Rust does have global variables, but can be problematic with ownership rules. If two threads are accessing the same mutable global variable, it can cause a data race. In Rust, global variables are called static variables. Oh, this snake case, screaming snake case. Oh, hello world. By Mango, we have our screaming snake case. These naming methods are so dark. So we have, this is how I say hello world. And this screaming snake case. Yup, is how you use a static variable. Static variables can only store references with the static lifetime, which means the Rust compiler can figure out the lifetime and we aren't required to annotate it explicitly. Accessing an immutable static variable is safe. Constant and immutable static variable might seem similar, but subtle difference is that values in a static variable have a fixed address in memory, thus the value will always access the same data. Constants, on the other hand, are allowed to duplicate their data whenever they are used. The difference between constants and immutable static variable. static variable have a fixed address in memory, and using the value will always access the same data, and constant can duplicate their data whenever they are used. And another difference between constant and static variable is static variables can be immutable, but constant cannot be edited. So basically this is like accessing or changing a global variable, static, mutable static variable. And it's unsafe because there might be data erase. Oh. Static mute counter equals to 0. Function add to out. Unsafe. Counter plus equals to increment. So this code adds some numbers to the static mutable variable counter. And even printing it is unsafe. I guess that's why it needs to be Screaming Snake case. We know a Screaming Snake is absolutely unsafe. Come on. The print is unsafe because you might try to read it at the same time that someone else is writing. Bam! Data rate. Bam! That's why it's unsafe. Name mangling fixes overloaded identifiers. The issue of same identifier being used in multiple contexts or assigning the identifier multiple meanings, making it unique. We're infiltrating bio area networks, which if you are interested is port 10427612762 and 111112. Do you remember those numbers by heart? That's so geeky. That's so geeky. Okay, we have learned the so-called global variable in Rust. Wait, it wasn't global variable. The name is static variable, and it can be mutable, but we need to say it's unsafe. It's unsafe. Implementing an unsafe trait. Oh, so traits can be unsafe. Another use case for unsafe is implementing an unsafe trait. A trait is unsafe when at least one of its methods have some invariant that compiler can verify. We can declare that a trait is unsafe by adding the unsafe keyword before the trait and marking the implementation of the trait as unsafe too. So if one of the methods has some invariant that the compiler can verify, the trait is unsafe. By using unsafe implement, we are promising that we'll uphold the invariant that the compiler can't verify. So the sync and send marker trade in chapter 16 automatically implements this trait automatically if our types are composed entirely of sync and send types. If we implement a type that contains a type that is not send or sync, such as raw pointers, and we want to mark that type as send or sync, we must use unsafe. Rust can verify that our type upholds the guarantee that it can be safely sent across threads or accessed from multiple threads. Therefore, we need to do those checks manually and indicate as such with unsafe. Okay, so we can implement for unsafe trait and we need to label them as unsafe. I work in security for health industry. Those are kind of good numbers to know. Oh, that's so cool. Dang, that's a really important job. Thank you for protecting us. Welcome, Rocher. Hello. Okay, moving on. We have. Wait, what? Wait, what? I've been having high expectation for this union thing, and it doesn't even give me an example. What is the reference? Union. Oh. A union declaration uses the same syntax as struct declaration. Oh. Okay, so it's really like a struct. Oh, wait. It reminds me, I think C language also has union? I do remember it, but I never seen it being used. No mango. Yeah, but you guys are going to write things wrong after watching my stream. You guys are going to learn all these mangoes and doggos and neckos, and they confuse your mind. You're going to write cat language in your next coding session. Not gonna lie. We want to use unsafe code. Using unsafe, you'll take one of the 5 actions, superpowers. Just discuss isn't wrong or even frowned about, but it is trickier to get unsafe code to correct because the compiler can help uphold memory safety. When you have a reason to use unsafe code, you can do so, and having the explicit unsafe annotation makes it easier to track down the source of problem when they occur. So, don't be embarrassed to be unsafe. Nice. C has unions and they work pretty much exactly the same way. Nice. In particular, those are the ports for econ medical, which is stuff like X-ray data runs through. Oh my god. I can't imagine if like hacker groups attack medical facilities. It's gonna be a mess. I hope those things never happens. Okay, advanced trade. We first covered the trades. Defining shared behavior. But as with lifetimes, we don't discuss the more advanced details. Okay, I do I wanna go back to see if I'm missing anything. Not really. Oh. Specifying placeholder types in trait definitions. Specifying placeholder types in trait definitions with associated types. What is associated types? Associated types connect a type placeholder, with a trait, such that the trait method definition can use these placeholder types in their signatures. The implementer of a trait will specify the concrete type to be used in this type's place for the particular implementation. That way, we can define a trait that uses some types without needing to know exactly what those types are until the trait is implemented. A type placeholder with a trait. Associated types, they're used more rarely than feature explained in the rest of the book, but more commonly than other features. Okay, so this is quite common. One example of trait with associated type is Iterator Trade that the standard library provides. The associated type is named item and stand in for the type of value the type implementing the iterator trait is iterating over. Okay, so we have this iterator, a public trait iterator, and it has a type item, which is a placeholder type. And the next method definition has the item. Implementers of the iterator trait will specify the concrete type for the item, and the next method will return an option containing the value of the concrete type. Associated types might seem like a similar concept to generics, in that the latter allows us to define a function without specifying what types it can handle. So why use associated types? What's the difference? Those two accomplish the same thing. This uses the generics for the type, and this uses associated type. When using generics, we must annotate the types in each implementation, because we can also implement iterator string for counter or any other type. We could have multiple implementation of iterators for counter. In other words, when a trait has a generic parameter, it can be implemented for a type multiple times, changing the concrete types of the generic type parameter each time. When we use the next method on counter, we would have to provide the type annotation to indicate what implementation of iterator we want to use. So it is saying when we are implementing it using generic parameter, it can be implemented for a type multiple times, changing the concrete types of the generic type parameter each time. We need to provide type annotation to see which implementation we want to use. But with associated type, we don't need to annotate the types because we can implement a trait on a type multiple times. We can only choose what the type of item will be once, because there can only be one implement iterator for counter. We don't have to specify that we want an iterator of integer values of unsigned integer value everywhere that we call the next on the counter. So it's saying with if we use associated type like this item example, there will only be one implementation. We don't have to specify that we want an iterator of certain types. Okay. In other words, generics means that from A and from B are two different traits. But iterator is one trait, no matter what items associated type you choose. Oh. It has one trait. The associated type connect a type placeholder with a trait, such that the trait method definition can use this placeholder types in their signatures. So we can define a trait that uses some types without needing to know exactly what those types are until the trait is implemented. Choosing the associated type is like the body of the method, part of the implementation. If it is only one type that makes sense, then use associated type. So there will only be one implementation. Wait. We can only choose what the type of the item will be once, because there can only be one implement iterator for counter. Okay, I think I sort of get it. Sorry for the silence. I was trying to move my neck or brain. Move on. Default generic type parameters and operator overloading. That is processing. Yes, I have some processing bar or this little circle thingy moving on my head. Please wait. Operator overloading. Default generic type parameters. I feel like I'm reading German. Default generic type parameters and operator overloading. When we use generic type parameters, we can specify a default concrete type for the generic type. This eliminates the need for implementers of the trait to specify a concrete type if the default type works. The syntax for specifying a default type is for placeholder type equals to concrete type when declaring the generic type. So there can be a default type if I don't tell what the type is. Wait until you get your first higher rank trade bump. I'm gonna cry. I'm gonna cry. I'm gonna cry. A river. A rust river. A great example of the situation where this technique is useful is with operator overloading. Okay, it's operator overloading. It's customized behavior of an operator in particular situations. So basically you declare your own structures, your own structs, and you allow them to add together. Rust doesn't allow you to create your own operators or overload arbitrary operator, but you can overload the operators and the corresponding traits listed in standard ops by implementing the traits associated with the operator. We can overload the plus to 2 point. Oh, this is making some sense. This is making some sense. Wow, it's deriving a lot of stuff. Debug, copy, clone, partial equal. What do we have? We have a struct of point. So we want to print it, we want to copy clone it, we want it to be comparable. This beautiful point. And we can implement add a point. And we can use the plus sign for it. So type output equals to point. So we are going to output a point and function add self order. So a point adds another point. Return a point, and this is the point being returned. I'm just using web and I closed the entire editor. Just never happened This is how? I didn't know I sucked this much at whim. How did I close it? I'm confused. What? What now? Now the whole editor hates me. Oh, Cyan, calm down. It's all okay. It's missing a main function. Dang it, do you have to be so mad? My analyzer is going crazy. And my code is here. There's autosave. I'm fine. I'm just writing my code and suddenly I closed the whole thing for no reason. I don't know why did I press. I'm just replaying X with Y. Anyhow, anywho. So we're trying to add 2 points together and we want to make it equal to them plussing together. Okay. The stupid squiggly lines are finally gone. And it passed. Easy peasy, lemon squeezy, just like that. So we implement the add method. For the point, I can just use the add. Use the plus sign. Bing bong. The default generic type in this code is within the add trait. What do we have here? The right hand side itself. Type output. And the function add. That was for a sec. Dang, I didn't know Rust editor is this revengeful. It's definitely going for me. This code should look familiar. A trait with one method and associated type. We come back associated type. The associated type is output. So here is also output. The new part is this. This is the default type. This syntax is called default type parameters. The right-hand side generic type parameter defines the type of right-hand side parameter in the add method. If we don't specify a concrete type for right-hand side when implement the add trait, then the right-hand side will default to self, which will be the type we're implementing add-on. So this is making sure the things we're adding together has the same type. When we implement add for point, we use the default right-hand side because we wanted to add 2 points instance. Let's look at an example of implementing the add trait where we want to customize the right-hand side type rather than the default. We have 2 structs, millimeters and meters, holding values in different units. This thing wrapping of an existing type in another struct is known as new type pattern, which we describe in more detail later. We want to add values in millimeters to values in meters and have the implementation of add do the conversion correctly. Okay, so we are adding 2 different struct. Use std oops add dot millimeters on line 32. Oh, meters. We probably need to specify the right hand side. Yep, so we are adding meters to millimeters. Welcome, Fabian. Hello. I know Russ is cool. I'm trying to be cool. I'm a cool cat. So we're trying to add meters for millimeters. And the type output is gonna be millimeters. And function add self orders meters returns millimeters. Self dot zero. Why is it self dot zero? Oh, we're trying to find out the value. In millimeter, and we add the meter converted to millimeter. And don't panic it. Don't panic it. Oh, it's double struct. I forgot that again. The fields have numbers instead of names. In the main function, I don't wanna panic yet. Wait. Okay, squiggly got down. Assert equal millimeters 30 plus meters 1. What does it equal to? Boing, boing, boing. It will equal to millimeters 130. I'm a math genius. What? Why? It cannot do equal. Oh, do I need to do all the partial equal thing? How do I do that? Don't know. Okay. Debug. Still no? No comparison out of the box ever. A local variables with... Oh, it's supposed to be others. Look at me. I'm baka. Okay. Is it equal? It is equal. Nice. So we can add different types. Amazing. No comparison out of the box. That's true. That's true. Okay. Where are we? You'll use default type parameters in two main ways. You extend a type without breaking existing code to allow customization in specific cases most users won't need. What? Oh. What is it? What is it saying to allow customization in special cases most users don't need? It's okay. So the tiny rare user might customize. Is that what it is saying? The standard level is add tracing example. Okay. If you want to add a type parameter to an existing trait, you can give it a debug to allow the extension of functionality of trait without breaking the existing implementation code. Okay. Okay. Fully qualified syntax for disambiguation. Calling methods with the same name. What is this? So we're telling the difference between methods with same name, right? Nothing in Rust prevents a trait from having a method with the same name as another trait's method. Nor does Rust prevent you from implementing both traits on one type. It's also possible to implement a method directly on the type with same name as methods from trait. When calling methods with the same name, you'll need to tell Rust which one you want to use. So we have a pilot and a wizard. And both can fly. Of course. We can then implement both traits on the type human that already has a method named fly implemented on it. Okay? Distro Ubuntu. Oh, what's my distro? Wait, pilot. It makes me want to do Linux stuff more. Oh, that was not a pilot. This is a pilot. Trade wizard function fly stuff. So we are trying to call the correct fly when everybody can fly. Then who is the one that actually flies? Implement pilot for human. Function fly self incline. This is your captain speaking. Oh, this is so fancy. I just say this is pilot. I like things straight and clear. Have ya. See you. Good night. Looks like I like to misspell pilot. And implement wizard for human. Oh my god, I spell it wrong twice. 丽丽好耶，欢迎。This is a wizard. It's like up. Oh, wizard is funny. And implement human. I just type it. I don't wanna accidentally close my ID. I'm a human. Amazing. It's bugging me for the main function. So let person equals to human. So we have a human and we ask it to fly. And it says, I'm a human. I'm a human. How do we turn this normal person into a wizard or pilot? This is what we do. Oh, I like programming. You let me do magical stuff. Now we ask this person to become a pilot. This is pilot. And now we let this person becomes a wizard. And he becomes pilot first and a wizard and become human. Magic hacker neko potato. Cyan no. And yes. This feels familiar. I feel like other languages sort of like this. Associated functions that are part of traits don't have the self parameter. When two types in the same scope implement that trait, Rust can't figure out which type you mean unless you are fully qualified syntax. For example, the animal trait has the associated function baby name. Baby name, the implementation of animal, will struct dog, and the associated function baby name defined on dog directly. A baby dog is called. Wait, what is a baby dog? A dog baby? Am I a cat baby? Gosh. So what do we have? We have a trait that's animal. An animal has a baby name, and we have a dog. And dog is Spot. And baby name for dog is also Poppy. A baby dog is called what? A baby dog is called Spot. Spot. Cat Poppy Science. Cat baby. Cat baby. I'm a cat baby. Watashi koneko desu. A trait with an associated function and type. A trait with an associated function and a type with an associated function of the same name that also implements the trait. It sounds like a tongue twister. A trait with associated function and a type with an associated function. A trait with an associated function and a type with associated function of the same name that also implements the trait. But it calls the dog's baby name, so it's Spot. It's Spot. All puppies Spot. All puppies are Spot. What happens to the dogs that doesn't have spots? The admin 欢迎 which is implemented in the baby name associated function that is defined on dog. Baby name associated function on dog. The dog type also implements the trait animal, which describes the characteristic that all animals have. Puppy. We call dog baby name function, which calls the associated function defined on dog directly. We want to call the baby name function that is part of the animal trait that we implemented on dog. So the code prints a dog baby is called a puppy. Yeah. A baby dog is called a puppy, not Spot. So how do we access it? How do we make that happen? We need to show that we want to use this animal trait. Oh, look at this. This is how we do it. We use dog as animal baby name. Rah, that works. That's how you do it. You don't do animal baby name. You specify it's dog as animal baby name. And then it's going to print a puppy. Puppy. This is the syntax. Type as a trait. Dog as animal. That's why it's associative function. Oh. Wait. What's the title of this? This is trying to teach us calling method with the same name. The legendary reverse turbofish. What is turbofish? What is turbofish? Turbofish? What is Rust turbofish? Oh, it is the equals. No, it's the less than and the greater sign. That's the turbofish. That's so cute. Oh, wait, turbofish looks so stupid. I thought it's gonna be cute, but it's flat. What is a turbo? It's the worst thing that I can get from Animal Crossing. I don't like turbo. I like turbofish. We need to specify a type parameter on the method. Oh. 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 That's the turbofish. Oh, that's so cute. That's actually a little cute. Alright. Using super traits to require one trait's functionality with another trait. There are Superman and there are super traits. Is it like super class? To require one trait's functionality with another trait. Sometimes you might need some trait to use another trait's functionality. In this case, you need to rely on the dependent trait also being implemented. The trait that you rely on is the super trait of the trait that you're implementing. Okay. So if I'm borrowing money from my mom needs to exist, and my mom is a super trait because she's super mom. Ross chose this because it's easier to parse. What an amazing way. Ah, so Rust has kinda arguably inheritance because it has super trait. We want to make an outline print trait with an outline print method that will print a value or framed in asterisk. Oh, asterisks. Okay, so we put this sad numbers into a frame. Why? But okay, I'll do it. The implementation of outline print. In the implementation of outline print, we want to use the display traits functionality. Therefore, we need to specify that the outline print trait will work only for the types that also implement display and provide the functionality that outline prints needs. We can do that in the trait definition by specifying outline print display. This technique is similar to adding a trait bond to the trait. Wait, who depends on who? Who's the mother? We want to use the displays trait functionality. Oh, so this only works for the types that implement display. We can use this in the trait definition. So here it's saying it only works on the types that implement display. Display is the mama. Display is the parent here. Because we have specified it requires the display trait, then we can use the toString function as automatically implementing for any time implement display. Okay, I feel this is actually kind of really useful. Let's see what happens when we try to implement outline print on type that doesn't implement display. It doesn't. This point doesn't implement display. But it says the point doesn't implement display, and it couldn't work. To fix this, we implement display on point and satisfy the constraint that outline print requires. So it implements display for the point, and then it can be framed. This pattern is really useful for extension traits like byte order ready, byte X, and Tokyo IO async write. What are those? Google. Tell me the truth. Tell me the truth of humanity and the universe. Too hard. Gives up. Using the new type pattern, you implement external traits on external types. A new type pattern create a new type in a tuple struct. The tuple struct will have one field and be a simp wrapper around the type we want to implement the trait for. Then the wrapper type is local to our crick, and we can implement the trait on the wrapper. New type is a term that originates from Haskell programming language. There is no runtime performance penalty for using this pattern, and the wrapper type is elided at compile time. What is elided? Omitted. The wrapper is boom. Elided. Disappears. I want to implement a display on vector. Which we cannot do because display trait and the vector type are defined outside of our crate. Oh, we can make a wrapper struct that hosts an instance of vector. Then we can implement display on the wrapper and use the vector as a value. Oh, that's a nice workaround. So we really have a wrapper. Anyhow, wrapper is not a keyword, it's a struct. And this struct take a vector, and we can implement display for the wrapper. This is smart. The implementation of display uses self.0 to access the inner vector t because wrapper is a tuple struct and vector t is the item at index 0 in the tuple. Yes, then we can use the functionality of display type on wrapper. The downside of using this technique is the wrapper is a new type, so it doesn't have the methods of the value it is holding. We would have to implement all the methods of vector t directly on wrapper, such that the methods delegate to self.0, which would allow us to treat wrapper like vector. If we wanted the new type to have every method the inner type has, implementing the derived trait on the wrapper to return an inner type would be a solution. If we don't want the wrapper type to have all the methods of the inner type, we would have to implement just the method we want. Oh, okay. Now you know the new type pattern is used in relation. How the new type pattern is used in relation to traits. It's a useful pattern even when traits are not involved. Okay. Today is pretty eye-opening. It's pretty eye-opening. There are many concepts that I was not familiar with. But we did it. We went over the Unsafe Rust and Advanced Trait. I guess I'll call it for today, and next time we'll go over advanced types, advanced functions and closures, and the macros. And next time we're going to do the final project, which I'm super excited about. A multi-threaded web server. How will it look like? It's gonna be fun. Anyhow, thank you for coming to the stream today, and I'll try to schedule the next 2 Rust stream to next week sometime. I want to finish reading the Rust book next week, and I'll see how the things goes. So for now, there won't be the weekly schedule. I'll schedule the stream directly on YouTube. And hope everything goes well. Elation is when programming language decides a necessary part of code can become optional or omitted. This is a technique to optimize compiling and eliminating unnecessary copying of objects. Where did we... I know I saw the word. Where did the deletion go? Elation is gone. Is that why it is elation? Thank you for subscribing. X539. Yeah, I feel it is really good right here. The wrapper type is deleted at compile time. Oh, I see. Yes, the wrapper disappears. The wrapper is ignored. Nice. Thank you guys for teaching me. I really had a great time, and I feel a little more powerful and comfortable with Rust. I wanna build something. Even if I'm not streaming. I would still like to write Rust on my resume, you know? It's been really great reading this. Oh my god, my cat is here. Hello. You made the last appearance on my stream. Alright, I'm going to end the stream now. Thank you guys for coming and have a great rest of your week. Bye bye. Oh my god, my cat. Hello. Thank you, Adam. Thank you, 0x539. Thank you, Sangune. See you next time. Bye bye, Ming. Bye bye, Bima. There will be a next time. Don't worry, Sangune. It's gonna be fine. Thank you, Jules. Thank you, Dragon1320. Thank you, Roboto. Bye bye, Sue. Bye bye. Oh my god, my cat is taking over everything. Bye bye, Lily. See you next week. Next time. Bye bye, my cat. Say goodbye to everyone. Say goodbye. He doesn't want to talk. He doesn't want to talk. Bye bye. I'll perform some cat spanking. Does he like to spank? He's a very good boy. Come on. You hear nothing? This is my cat. Oh, he's trying to eat me. He's trying to eat me. Oh, I'm dead. Bye.